All right, at this point, we're ready to do a full projection on polynomials. So example 4.2.5, consider P3 with inner product. Let's use the integral inner product. I want to find an orthogonal basis for the subspace, span of 1x, x squared. So you can think of W as P2 really. All right, so I want to find an orthogonal basis. So that means I'm going to use U1, U2, U3. That's going to be 1x, x squared. I'm going to apply the Gram-Schmidt process to this. So I'm going to take V1 equals U1. That's 1. I need to project away from V1 when I construct V2. So that's going to be a product of x, well, U2, V1, 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 V1. And so I'm going to get, that's x minus the product of x and 1, x and 1 and 1, sorry. 1. All right, let's compute x and 1 on the side here. That's going to be the integral from -1 to 1 of x. So that's x squared over 2 from -1 to 1. That's 1/2 minus 1/2, that's 0. All right, so this part gives 0, so I end up with simply x. All right, so V1 and U1 and U2 were already orthogonal. Let's construct V3. That's going to be U3 minus U3 V1, V1 V1, V1 plus U3 V2, V2 V2, V2. All right, let me compute them here. So I'm going to take, oh wait, let me write what this is. This is x squared minus x squared 1, 1, 1, 1 plus x squared x, 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 x. All right, x squared 1, that's the integral from -1 to 1 of x squared dx. That's x3 over 3 from -1 to 1. That's 1/3 minus a third. That's 2/3. All right, and then 1, 1. That's integral from -1 to 1 of dx. If you use a property, that's just a rectangle, so it's 2. All right, so that means I have 2/3 divided by 2, 1. All right, next up, x squared x. That's the integral from -1 to 1 of x cubed. You could use this as an odd function and say it's just 0, but let's spell it out. I get 1/4 minus a fourth. I get 0, so plus 0x. And so my third basis element is x squared minus a third. All right, so the basis I'll be using when computing projections onto P2, onto W, is this basis here. All right, part B, consider P of x equals x cubed plus 1. Find the projection onto W of P of x. All right, let's write the formula, projection onto W of x cubed plus 1. That will be, all right, so I take the inner product of x cubed plus 1 with my first basis element. I take x cubed plus 1 inner product with the second basis element. And I take x cubed plus 1 with the third basis element. Sorry, it's a bit let's compute all of these on the side. So x cubed plus 1, 1. That's just the integral of x cubed plus 1. I get x4 on 4 plus x from minus 1 to 1. That's 1/4 plus 1 minus a fourth. All right. So it's 1/4 plus 1 minus a fourth minus 1. I get 2. 1, 1 is already computed up here. It's 2 as well, so I get 2 over 2 times 1. All right, let's compute the next one here. If I use x cubed plus 1 times x, that's minus 1 to 1, x4 plus x dx. I get x5 on 5 plus x squared on 2. That's going to give me, this part is going to give me 0. The other one is going to be 1/5 twice, so 2 on 5. Right, so plus 2 on 5. Let me give you this one pretty quickly. I mean, the pattern is not so tough if you pay attention. For even ones, you get 2 from the top and plus 1, so that's going to be 2/3. That's times x. And finally, x cubed plus 1, x squared minus a third. This one I computed ahead of time, and it's 0. And so I get 0 times x squared minus a third. And so the projection will be 1 plus 3/5 x. All right, so this is the polynomial in W, which is P2, closest to x cubed plus 1, obviously closest using this inner product. All right, in the next section, we'll be looking at approximation using projections. So how can we use this on everyday problem? How can we use this to solve things that are a bit more concrete than just randomly projecting things down?